Okay, so now that we've had some practice making a map with ggplot and adding layers to depict geospatial information, let's start with one of the more specialized approaches to map making using OpenStreetMap. OpenStreetMap is a free open source geographic database that's maintained and updated by a dedicated online community of collaborators. It uses its own system to identify geographic information and features like parks, roads, and buildings, which can then be queried and used in a variety of geographic information systems or GIS platforms. We'll use an R package in this section of the tutorial called OSM data that allows us to query OpenStreetMap and map features of a few cities in Switzerland. We'll also cover how to create a focus area using different geometry projections and make our maps a little bit more professional looking. Okay. So first, let's load some new packages that will be essential for working with OpenStreetMap data. I'm in the section of the Markdown that loads new packages, including OSM data and the SF package. So like I said, the OSM data package allows us to download and use data from OpenStreetMap. And the second package is SF, which allows us to translate graphic simple features into R objects to plot. Okay, so if we scroll down to the next code chunk, we'll first use a function called OPQ to query OpenStreetMap and get two geographic features for Zurich, the largest city in Switzerland. These queries may take a minute or two to run depending on your computer and internet connection. Ooh, I need to add my packages. So I'm going to get those started while we kind of overview a few additional pieces of information here. So using a tidy piped statement, so these are noted with the kind of straight up and down bar and the arrow. This is the updated approach to the %, arrow, % that some of you may be more familiar with. You can use either, they work exactly the same way. So we're going to use a piped statement to tell the OPQ function which city we want to query, the feature we want to grab, and to return that query in SF format. We want to save each query separately so we can layer these features into our eventual map. Just to note, as you'll see in the OPQ function, we're using a statement called Zurich, CH as the string to query the city of Zurich. And that's because the Latin words Confederatio Helvetica means Swiss Confederation. And fun fact, the typeface Helvetica was developed and aptly named in Switzerland in the 1950s. So little fun fact about typography for you there. So we will query Zurich using the OPQ function. And then from that kind of baseline query, we want to use the function add OSM feature and tell OpenStreetMap which features we want to grab. So in this case, we want to get roads. So we'll get everything that's tagged as a highway. And then the final line of the piped statement that says OSM data _SF, that's just telling OpenStreetMap to return our data in SF format. And we're going to save all of that information into an R object called Zurich _roads. I'm going to do the same thing, this time now using a key equal to water to get all sorts of waterways and water features for the city of Zurich. So again, this chunk of code might take a minute or two to run for you, depending on your computer and your internet strength. But once you have that loaded, you'll see that you have two SF objects now in your R environment, containing the roads and water features for Zurich. We can use ggplot again, now in combination with a geom called geom_SF to actually plot these features. And an important thing to note with these types of OpenStreetMap queries, we get multiple types of shapes returned. So we get lines and polygons. Depending on the feature you're mapping, you may want to use lines sometimes and polygons other times. So for example, we want to use lines when we're mapping roads and polygons when we're mapping bodies of water. And we need to specify these features from these new returned objects using the $ symbol when we tell geom_SF which data we want to plot. In this case, we're actually even going to use a special kind of polygon called a multi-polygon, which is it's just made up of multiple polygon elements. And this can be really useful when plotting detailed shapes, especially for geographic features like water. So now if I go down to the first plotting code chunk in this section of the tutorial, I'm going to start with my basic ggplot layer, and to it, I'm going to add two geom SFs. The first is specifying that I want to take the OSM lines from the Zurich roads object, and I also want to take the OSM multi-polygons from the Zurich water data. So this might take about 5 to 10 seconds to run. And when we get the map plotted with this like really basic set of geomes, we see a pretty ugly mess. So we can see kind of our water shape. So we can see that we have a pretty big lake here. We have some rivers. And then we just have this mess of a square of a bunch of lines that are like really thick and dense, and we can't really tell what's happening in there. While this is pretty ugly, this is actually pretty interesting, I think, in terms of how it shows the data that OpenStreetMap gathered for us. So if we first take a look at these roads, we can see that OpenStreetMap queried all the roads in a given area and pulled information in this kind of square shape. This is because it's using something called a bounding box or a B box to define the query area by 2 longitudes and 2 latitudes. So it's literally creating a bounding box for the query. This is useful in theory, but I have found that I rarely want to define a map's boundaries by this type of bounding box, and more often I want to use administrative boundaries, so the boundary of a given town or country, or a shape I define myself, which is what we'll be doing in this tutorial. Okay, let's look at the water. Because we're plotting a multi-polygon, we can see that we have water feature information that extends beyond the bounding box, even though the query was limited to the same B box as the roads. So now that we have a better sense of what's going on here, we can do some simple steps to make this map more interpretable. To do this, we'll first zoom in and focus just on the city center of Zurich. We'll define a circle around the city center coordinates for Zurich and limit mapping our OSM features just to that circle. So we won't have this big sprawling mess anymore. To do this, we first need to find the center coordinates for Zurich. And I did this just using a quick Google search, finding that the latitude is 47.3769 and the longitude is 8.5417. When you search this yourself, you'll see these values followed by degrees north and degrees east, respectively. And that gives a little bit of a clue about how you're plotting latitude and longitude. If we think of latitude as degrees of east and west around the Earth, and longitude as degrees of north and south. So in the next code chunk, we want to simply save these center coordinates as an object called Zurich Center. So I'm just defining a little list here that says my latitude is equal to about 47 and my longitude is equal to about 8.5. Using this center coordinate, we now want to create a circle around it. So we have a point in the middle and we basically need to define the distance, which is just the circle's radius, and draw a circle around that point. To do this, we need to specify something called the coordinate reference system, and that refers to the target coordinate system that we want to use to draw this circle. So in this case, we want to use the standard CRS that Switzerland uses. Oftentimes you'll find that a pretty commonly used CRS is 4326, which is the EPSG identifier of WGS84, and that's the latitude longitude standard coordinate system. So that was a lot of numbers and letters, but just know that 4326 is kind of standard, and then we can specify something more specific to Switzerland. So we basically just need to tell R to transform our circle around the city center into latitude and longitude using a secondary CRS that's local to the area that we're in. So for Switzerland, that value is 2056. And again, I just found that using a quick Google search. So if we move down to the next code chunk, let's break down exactly what's happening here. So what we are doing in this pretty big piped statement, is reprojecting our center coordinates to make a circle around them. So we first want to define the latitude and longitude of our circle using the center city coordinates. So we just create a little tibble using those latitude and longitude values for the center coordinate point that we just defined in the previous code chunk. We want to use a function called st as sf, which is basically kind of a catch-all function that transforms kind of any unrecognizable object in the simple features space to an SF object. So this is a really handy function that if you start making maps yourself, you'll find yourself using a lot. So I am then using that st as sf function to project these coordinates into standard space. So I'm saying to R that my coordinates will be longitude and latitude, and my coordinate reference system is the standard 4326. The next thing I want to do is transform this circle to my local CRS. So this is the one that Switzerland uses. So this is the 2056. So I'll use a function called st_transform to actually transform this circle from standard coordinate space to specialized Switzerland coordinate space. Then I want to define the distance of my buffer using a function called stBuffer. And we can think of this as defining the circle's radius. So I'm going to use a distance of 2000. Then what we want to do is retransform our circle back to the standard coordinate reference system space. So we transform back to 4326. So we kind of defined a circle, drew it in our area as defined by what Switzerland uses to project coordinates in its space. And then we drew the circle with our buffer distance and then transformed it back to a more standard space. So we have our two OpenStreetMap objects. We have our Zurich roads, we have our Zurich water, and now we have this defined circle for the Zurich city center. And we can use these together to get the intersection of all of these objects using a function called st_intersection. So we're basically overlaying our circle onto the information that OpenStreetMap gave back to us from our query and cutting anything that kind of falls outside of the circle boundaries. Using this st_intersection, we can save some new objects as cropped versions of the original. And again, this might take a couple minutes to run. So I'm going to go ahead and run that while I continue talking in the background. One thing that you might notice is getting a warning that says attribute variables are assumed to be spatially constant throughout all geometries. This is a warning that you can ignore because what we did in the previous step is basically ensure that we modify the data to make sure they are spatially constant by kind of retransforming back to this standard coordinate space. So I'll create two new objects, one that's called Zurich roads cropped and one that's called Zurich water cropped. And so when we get the returned objects from this st_intersection function, we'll just have kind of a subset of the roads and water features as defined by our circle. So we can use our new cropped data to actually make our new map. So to distinguish between our elements here, rather than having kind of black and gray for water and roads, I've added a few colors for the circle. I'm going to use white, I'm going to use black for the roads, and I'm going to use blue for the water. So now I have 3 geom SFs added to my ggplot. The first is specifying that my data is coming from the circle. So for this purpose, I'm drawing the circle itself, but this isn't a necessary step to ensure that your circle of data appears. This is more of a stylistic choice. So you can remove that if you wanted to. The second SF geom that I'm going to include is the Zurich roads cropped. I'm going to define a line width of 0.05. This will help ensure that there's not just this kind of jumbled mess of roads overlapping each other. And I'm just going to say that I want my roads to be colored black. And then I'm also going to add a geom SF for the water and fill it in with the color blue. So this will really help distinguish what features of my map are water and what is kind of roads and what's kind of the space in between. The next couple of things I'm going to add is coord SF. So this is similar to when we were adding our coord Cartesian, but this is now specific to using this simple features type of data. So if you tried to use coord Cartesian in this ggplot, for example, R would not be very happy with you because it would think, hey, you're using these simple features. You need to provide a coordinate system that's relevant to how it's seeing these simple feature objects. So kind of rule of thumb is if you're using Geom SF, you need to be using coord SF. And then finally, I'm just adding in theme void to remove any sort of axes and background from the plot, really to just make the kind of map stand out. So if I execute this line of code, we can see that we now have a much, much nicer looking map. We have a nice circle. We can see the lake that Zurich is on. We can see a whole bunch of roads kind of defined around the city center for Zurich. And it's just a lot cleaner and nicer to look at. So I think this is much better. And this is a really great starting point then for further customization. And one of the things that you can also do is if say you're making a whole map of Switzerland, for example, and you had information that you wanted to zoom in and say, this is specific to something in Zurich, this is specific to something in Bern, you can have maps like this that are these little inlets that you can kind of overlay onto a bigger map, kind of in the way that you'll see kind of zoomed in features on some more modern maps. So this is a really handy way to kind of make that more detailed section of a larger map. All right, so that's it for the OpenStreetMap tutorial. The next part of the tutorial involves a challenge for you to essentially recreate the same type of map, but using a different city in Switzerland. So go ahead and work on that, and then you can reveal the answer when you're ready, and I'll have a short video included as well that details exactly how to make this other new map. So yeah, best of luck.